Hey everyone. Back again. This time we're going to actually look at part E. So I'm going to save parts C, D, and F for you to try on your own. And I will post a scan of the solution for those problems right in the same location you see these video exercises, or video solutions, I guess. So that after you try them on your own, you can look and see if you did it correctly. Alrighty, so we're going to look at E. So E is actually, I would say, probably the hardest problem out of these 6 problems, which is why on your sheet you see a hint. So I said hint, write it as a sinusoid as we did in section 10.5. So at the end of section 10.5, towards the end of it, we went over rewriting certain functions as sinusoids so that we were able to create their graph. We can use the same sort of idea here. We actually want to make it so we can rewrite the left-hand side of the equation as a sinusoid. And to do that, we are going to use actually the difference formula for sine. So I'm going to remind you of what that is. Off to the side, maybe somewhere here, I'm going to write that down. I'm going to try to avoid this light, this glaring light. But we want to remember that sine of alpha minus beta, that's actually equal to sine of alpha times cosine of beta minus cosine alpha sine beta. That's what we're going to use. We're going to try to actually get this left side of this equation to look like this, okay? We already have a sine here. We're going to want to get a cosine of something here. We already have the cosine over here, so we want this to be a sine, but what we want is to see unit circle values. Right now there's technically a 1 in front of here. What could we divide these numbers by so that they turn into unit circle values? Did I hear you say 2? 2 is the correct answer. So we're going to go ahead and divide across everywhere by 2. Being that this is an equation, right, we can just divide all the way across by 2. And that's valid. So now we have 1/2 multiplied by sine x minus square root 3 over 2 multiplied by cosine of x is equal to 1. And like I was saying earlier, we want to turn this value right here, this 1/2, we want to write it as a cosine. I'm going to leave it blank for right now, but we're going to come back in and fill it in. And we want to write this square root 3 over 2 as sine. I'll leave it blank for right now, we'll come back and fill it in. Okay, so I want to fill the same angle value in here as I do here. So we want to think right now, where on the unit circle is sine equal to square root 3 over 2 and cosine equal to 1/2? So cosine 1/2 sine square root 3 over 2, that happens at pi over 3, right? So we're going to plug pi over 3 into here, and we're going to plug pi over 3 into here. And then we're going to compare, okay? Compare what we have on the left-hand side of this equation by this formula over here. Don't we have a sine times a cosine minus a cosine times a sine? We do, right? So that means we can simplify it. We can condense it in to make it look like just this. So we're going to have sine of, we want to take alpha minus beta. Alpha was inside of the sine function to begin with, right? So alpha is actually x. So we need to start with x here. And then we're going to subtract beta, which is pi over 3 in this case. And it still equals 1. Okay, so we're down to sine of x minus pi over 3 equals 1. Now, this should look like a problem that we had, you know, towards the very beginning of this section, actually. It's just a problem where we just use a simple substitution to solve it. So we're going to where we make our substitutions for whatever's inside of the trig function, if it's more complicated than just x. So I'll use u. I'll let u equal x minus pi over 3. And then we'll go ahead and plug that in. So we have sine of u is equal to 1. So you're asking yourself, all right, where does sine equal 1? Where does the y-coordinate equal 1 on the unit circle? Doesn't that just happen at the top of the unit circle? And that's it, right? So we're going to have u is equal to pi over 2 is the angle, plus 2 pi k. And that's it. That's solving for u. We have to now put the x back into the problem. So really we have x minus pi over 3 is equal to pi over 2 plus 2 pi k. Okay? And we're going to solve for x. So I want to add pi over 3 to both sides. So we get x is equal to, what's pi over 2 plus pi over 3? So you want to think common denominators, right, if you're going to do it in your head. We'd have to get them both to have a denominator of 6. This would be 3 over 6. This would be 2 over 6. So if I add 3 over 6 plus 2 over 6, I get 5 over 6, right? So 5 pi over 6 plus 2 pi k. Bam! There it is. Now, what are our solutions within 0 to 2 pi? Okay, what are our solutions within 0 to 2 pi? Well, if k is 0, we get a solution of just 5 pi over 6. If k were 1, we would have to add 2 pi onto that, but that's going to be too big. And we don't want to subtract 2 pi off of it because that'd be too small. So it looks like we only have one solution to this problem. Okay? Now, if you wanted to check this solution, what you would want to do is, well, you could take it and plug it in, right, and just type in your calculator and see if it equals. Or we could graph. What I would suggest doing is to check it. You could graph y equals the original problem, which was sine x minus square root 3 cos x, and then if minus 2, okay, because you want to have it equal to 0. If you graph that on the interval just from 0 to 2 pi, you should see the graph crosses the x-axis at only that value. So I encourage you to check that out. This video is getting a little bit long, and it takes, I have really crappy internet, so it takes forever to upload stuff. So I'm going to go ahead and cut it short and just leave that as an exercise for you to complete. All right? Bye.